Alright, so we got kind of a really quick one today, reviewing piecewise functions, and we'll have some rates of change practice for the free response. So we're going to evaluate continuity and
Okay.
differentiability of piecewise functions, and then figure out what the average value is going to be of the piecewise function, which I don't think we've done yet, but the principle is going to be the same as getting the average value normally. So before I jump into this, if I had a piecewise function, um, how would I prove that that piecewise function was continuous?
How does a piecewise function looks like again?
So piecewise function would look like a function that's defined in two parts. So for instance, let's say f
Oh,
of
okay.
x is equal to x plus 1 if x is less than 2. And then if x is greater than or equal to 2, we'll say this is um, so we'll do something like this.
So we plug in 2 in both functions.
Okay.
If it's the same result, it's continuous.
Okay, so for this one I just came up with, if I plug in 2 to the top, I'll get 3. If I plug in 2 to the bottom, I'll get 4 minus 6 is negative 2, plus 5 is also 3. So is this continuous at x equals 2?
That's 2, yes.
Yes. Okay, awesome. Junho, if I wanted to prove that this is differentiable, what would I have to do?
You derive and
Okay, so I'm going to derive both the top and the bottom, plug it in and see if we get the same result. So if I derive the top, what happens?
1.
1. Okay, so f prime x equals 1 if x is less than 2. And then f prime is equal to something if x is greater than or equal to 2. What happens if I derive the bottom part?
2x minus 3.
2x minus 3, so it
1.
also 1. Okay, so this is continuous. Is it differentiable?
Yeah.
Yes. Okay, now if we fail continuity, we automatically fail differentiability. So if this had been, we'll say x plus 2 instead, we could not be differentiable even though my slopes would still be 1 because we were not continuous. To be differentiable, we must be continuous. To be continuous, we must have a general limit at that point. Okay, any questions on piecewise functions?
No.
Okay, can you guys see the red on this? I know the colors are kind of similar. Is the red writing okay, or should I change color? Okay. I assume that means we're okay. So I've got this piecewise function defined as root x plus 1 from 0 to 3 included, and then 5 minus x from 3 not included to 5 included. I want to know, is this function continuous at x equals 3? And then why or why not? Okay, so what do I have to do here?
Yes, it is.
I'm sorry, say one more time.
Oh, super. it is continuous because if you plug in 3, the result is both 2.
Okay, so f of 3 equals 2 if 0 is less than or equal to x is less than or equal to 3. Since that's the square root of 3 plus 1 is 2. Okay, and then f of 3 is still 2 if 3 is less than x is less than or equal to 5, as 5 minus 3 is also equal to 2. Okay, so we can say f of x is continuous at x equals 3. As the general limit as x approaches 3 is 2, and f of 3 is 2. Okay, so to be continuous, we have to prove the general limit and what happens when we plug it in, which is kind of what we've done here. If we are taking the limit as x approaches 3 from the right, then I would end up using the bottom one, right? So this would be something like this. This bottom part we did here is the limit as x approaches 3 plus a little bit, equal to 2. Top one is the limit as x approaches 3 minus a little bit is 2, and what happens when we plug it in, so this is less than or equal to. Okay, any questions on part A?
No.
Okay, then B. I want to find the average value of f on our interval from 0 to 5. Okay, so this is new, I think, but we should be able to piece it together. Junho, in general, how do we find average value?
Uh, F F of B minus F of A over B minus A.
So that's average slope, I think.
Uh, oh,
What do they mean with average value?
So average value means our units won't change, but I want an average. So I want the average y value of our function from x equals 0 to x equals 5. Versus an average slope would be like our
Okay.
average derivative. Okay, so average value. Does anyone remember the formula from the formula quiz? Okay, so this is 1 over b minus a times the integral from a to b of f of x in terms of x. Okay, so we are integrating our
Oh,
function,
okay.
so we're stepping up, and then I'm dividing by the total x values that we covered, which will step us back down, so our units don't actually change. And that gives us an average y value for our function. Okay, so I want to do this, but for our piecewise function, so I want 1 over b minus a, so that's 1 over 5 minus 0, times the integral from 0 to 5 of f of x. That integral from 0 to 5 of f of x will need to be split. How can I split up this integral from 0 to 5 of f of x? Where do I need to split this so that we can get the areas?
So the root of x plus 1 minus 5 minus 6.
Okay, I can use the root of x plus 1, but from x equals 0 to x equals what? So we have different functions for different parts of this interval, so I can't just integrate from 0 to 5 using the top function. So for what x values is the top function true?
G.
Okay, we can go to 3. So this is the integral from 0 to 3 of the square root of x plus 1. Okay, and then because integration is just addition, I'm going to add the integral from 3 to 5 of our bottom part. 5 minus x in terms of x. Okay, that way we'll get the area that's underneath the curve all the way from 0 to 5. So this integral from 0 to 3 of root x plus 1, root x plus 1 is the same thing as x plus 1 to the 1/2 power. So what would happen when I integrate x plus 1 to the 1/2 power? What's my inside part?
X plus
X plus 1.
What's the derivative?
1.
1.
Okay, I'm going to write dx, but yeah. So I can rewrite this as the integral of u to the 1/2 power du. What will happen when I integrate u to the 1/2 power in terms of u?
You prime. 1/2 you prime. You driving or?
No. So this is integral.
You over pi?
What should my power be?
Negative 1/2.
I'm not deriving.
Or negative. Negative 3/2.
This would be positive 3/2. So that's 1/2 plus 1.
Yeah.
And then I need to divide by 3/2, which is the same thing as multiplying by 2/3. Okay, now I do have bounds here from 0 to 3. So when we go to integrate this, this will be 1/5. This will be 2 times x plus 1 to the 3/2 power over 3. Which will be going from 0 to 3. Bless you. And then what happens when I integrate 5 minus x?
Mm.
5 minus x squared over 2.
What happens when I integrate 5?
So 5x minus x squared divided by 2.
Yep. 5x minus x squared over 2. From 3 to 5. Okay, so now I just need to plug in my numbers. So if I plug in 3 for this first one, And this will be, let's see, 2 times, I've got 4 to the 3 halves power over 3 minus 2 times 1 to the 3 halves power over 3 plus, when I plug in 5, this would be 25 minus 25 over 2. 25 minus 25 over 2. Okay. Minus 15 minus 9 over 2. And then I'm going to multiply all of this times 1/5. Okay, so this is 3 over 2. That over 2 means I'm going to take a square root first. So this is the square root of 4 is 2, raised to the third power is 8, times 2 is 16, divided by 3. So I've got 16 thirds minus 2 thirds plus 25 is 50 over 2. So this is 50 over 2 minus 25 over 2 is 25 over 2, positive. Okay, 15 is 30 over 2. 30 over 2 minus 9 over 2 is 21 over 2. Minus 21 over 2. Times 1/5. Okay, so that's 14 thirds plus 4 over 2. Or 14 thirds plus 2. 2 is 6 thirds. So that's 14 thirds plus 6 thirds is 20 thirds times 1/5. My 20 and my 5 will cancel, so that'll leave me with 4 thirds. Okay, any questions on what we did here?
No, no.
Okay, no, I kind of squished things together for that last step, but I'm a little concerned with the integral issues we had there, but so when I'm integrating, I'm always going to add 1 to the power, divide by the new power. If you need to make a u substitution, you can. We actually don't need a u substitution for this second integral, because that's just a polynomial. I'm raising everything to the first power. So we can integrate both those terms separately. Okay, then for part C, I've got this function where k and m are constants. G is differentiable at x equals 3. I want to know what the values of k and m are. Now, if g is differentiable at x equals 3, it must also be continuous at x equals 3. So that means we should be able to set up a system of equations for this. One set where we're proving continuity, and then another set where we're checking the differentiability after that. So if this is continuous, what has to be true about the top and the bottom?
The derive is equal.
Okay, the derivative is equal. That'll be one of our points. So for our differentiability, and then before
if we set the point x to 3 should be equal to.
Right. If we set x equals 3, then the top and the bottom should also be equal. So I'm going to do that first. If x is 3, then this will be 3 plus 1 is 4 underneath the root is 2. So this is 2k. I guess I'll do this in an extra step. This will be k times root 3 plus 1 equals 3m plus 2, or 2k equals 3m plus 2. And then, Junho, you mentioned if I derive this, they should also be equal. So I'm going to get our derivative first. This is a k, which is a constant. K times x plus 1 to the 1/2 power. Okay, and I'll need to derive that in terms of x. Should be equal to the derivative in terms of x of my opposite side as well, which is mx plus 2. Again, m is a constant, so I won't need product rule here. What happens when I derive k times x plus 1 to the 1/2 power if k is a constant?
Uh,
What happens if I derive the left side?
oh,
Uh,
1 over 2k
Perfect. So k over 2 times...
x plus 1 dx. Oh, negative
Negative
1
1/2.
over half.
Okay, cool. So the only reason why we did not need product rule there is because k is just a constant.
Since k is a constant.
Right. Okay, and then if I derive the right side, what's going to happen? So again, k and m are constants, so m is a constant.
And
Okay, then this will just be m. Perfect. Okay, so I'm going to simplify a little bit. And I've got dx, rather. Okay, so my dx's will cancel. I'm left with k over 2 root x plus 1 is equal to m. Okay, any questions on what we've done so far?
No.
no.
Okay. So if that's true, then we can use this to solve. So I could say I want to do this. I think we know what x is. This x plus 1 is going to be 3, since we just derived it at 3. So this is k over 2 times square root of 4, which is 2 times 2 is 4. So m is k over 4. So I'm going to take that. If m equals k over 4, I can plug that in here to get 2k is equal to 3 times k over 4 plus 2. And then we'll solve for k. So I'm going to move all of my k's to one side. This will be 2k minus 3/4 k. Should give me 5/4 k. Okay, so I've got 5k equals 8, or k equals 8 over 5. And then if k is 8 over 5, then I can plug that in here to get my m. So that's 8 over 5 divided by 4 is the same thing as times 1/4, should equal m. Therefore m, if I cancel, is 2/5. Okay, any questions on what we did here?
No.
No.
Okay. So I've got a handful of practice problems to try today from the free response. I'll jump into that really quick because I forget which number this one was that we just did. I believe we did the last one for number 6. I'm just going to double check. While I'm pulling that up, grades for the quarter are actually over on Friday. However, we've got the teachers have the next week to finish putting in grades. Which means the last day that I can change your grades for quarter 3 is Thursday of next week, because they have to print Friday. I don't know how they're going to get report cards to your parents. I imagine they will send directly via email to your parents. on
And
Friday
okay.
of next week. But please check GradeLink if you're missing any assignments. Finish the assignments that you're missing. Since we only have really this week and the weekend to try and fix stuff. So that if anything's wrong, we'll still have a couple days next week to fix anything that's still wrong.
Okay. Okay.
Not just for me, but for your other teachers too. I know things are a little bit hectic online. Okay, so we did number 6. That means I need you guys to do number 4 and 5 for the 2003 FRQ. And then we'll meet back again on Thursday, same time.
Which numbers again?
Numbers 4 and 5. So you guys already did 1,
Okay.
2, and 3 for homework previously. So we've got 4 and 5 left, and then we did 6 in class today.
Okay.
Okay, thank you guys. Thank you very much for coming, and I'll see you on Thursday.
Okay. Thank you.
Problem.
Yo.
Goodbye.